So Jose agreed to help me with that job. That's still good. Let me see. Lizeth, are you still around? No, Lizeth.
She's coming.
She's coming.
Yes, she didn't know where to go. She's coming.
Okay, good deal. Miss Marino, your number still's not been corrected.
I'm sorry?
Your number's not correct.
My phone number is 972-375-2925.
Yeah, that's what it is now. I got that.
Yeah.
Okay, let's see what else I have here. So, still missing Lizeth, and I think everybody else is pretty good. I got most everybody. Lizeth, are you here now?
Yes, I am.
Can you still be in charge of the book with me?
Yes, I can. I'm not able to view it.
You're not?
No, I'm still on the other class. Is it on the demon?
Yeah. It's the same book.
Oh, okay. Okay.
It's the same book, except we're moving forward on it.
I'll
All
try
right.
to look at it right now.
So if you guys have you guys don't even have, do you have the syllabus even?
No, I still have the old syllabus.
Wow. Let's see what I got here. Okay, so let's see. I got it right here. So do you have the last one you had? What? Today we're on Radican expressions and functions. Does that make sense? Based on what you had last time, we are starting today with 6.1. See if that makes sense. No, you've already had 6.1. It's the same one. Oh no, it is. It's not. Yeah, 6.1. What did you have last time? Do you remember? Did someone look at your syllabus last time?
We stopped on page 245.
0.5?
We stopped on.
We were behind.
We were 4.8. Applications of polynomials.
So, did you have let's see what I got here. Let me look at stuff. Okay, so you guys have had all the way up to 4 point something. You also had 10.3 according to this. We stopped at 4.4, 4.5, maybe a little bit further. Yeah, we stopped at 5.5, right?
No, we were behind, but that's the end of it. 5.5.
Last semester was 5.5, right?
We stopped at 4.8.
You didn't do any of the 5 stuffs?
No.
No.
I don't think we had one class because we couldn't log in. And then another one, we continued the midterm exam or
Right,
review.
hang tight, you all. Hang tight. So I can come up with you. Okay. Oh, 3154107. I'm going to try to do something here. Hold on. All right. See if you've got on your mail address the syllabus. I have sent it all to the other one, but you're not able to get it. See if you're able to get it through this one.
I received it. I received it.
You got it?
Yes, I got it.
Amen. It's a miracle we pulled this off because I had to reach into the old class to get your addresses and send you the information, which is the syllabus. So on the last page is the schedule. So it says we're starting out tonight at 6.1. Does that make sense?
Yes.
Yes.
Okay, so Lizette, I'm counting on you to keep us straight now on this.
Yes, sir.
All you have, and I'll see about fixing the other part, but I don't want to waste your time tonight and cancel class because we're already behind. So we don't want to do that. So we're gonna go right to 6.1. I got the attendance done. So is everybody still breathing okay?
Yes.
Yes.
And Louis, are you still there? Facundo? Jose, Louis, Facundo? And Selena? Selena, are you there? Miss Payne?
Brett has been negative towards.
Or Villafano?
Yes, I'm here.
Villafano.
Yeah.
You guys had the most amazing tests. I just wanted to, for that midterm, that was really beautiful stuff. So, and of course, there's always the standard cheering others. But see, Tamara, you're here.
Yes.
All right, I marked you in. You should have the syllabus and everything. You guys should have had this the other day. I sent all this stuff up this weekend, and unfortunately, you can't access that class. And I'll work on that. I got to call into a guy who's a wizard who can help. Okay, so let's go right into the class. Let's go there. I think I already got everything pulled up we need to for the book. Oh, no, we have here. Okay, so go to ETech. And we said we're going to go to 6.1. Because that's in the future. I hope you can look at your book and make sure that I don't know what page 6.1 is, but I got it this time. I think it's automatic. Radical expressions functions, you guys. Although I'm happy to hear you guys back again. You guys are a good group. Your scores were pretty good for your exams and for your course. I hope you all felt good about it.
Thank you, Mr.
Yes.
The only thing I'll share with you is this class is different. This one is going to be graded the same way. Participation, that of the films, midterm, final exam, one homework. See, you guys, did you guys have the homework assignment with the Honda?
Yes.
Yes, sir.
You guys will have to
Yes,
get a
we
new
did.
homework assignment. And I'll give you one. All right. No, don't do that. Well, okay, so now I think I can do this. I think I can bring you guys into the fold. All right. Hopefully you're seeing the book. Are you seeing it?
Yes, sir.
You are or you aren't?
Yes, we're seeing it.
Okay, the square roots of 64. The square roots of 64, you've learned before, are 8 and -8. They're always 2. And anytime if you have a question, you can ask. Of course, you guys, you got to talk to me. You can't raise your hand because I don't see a raised hand thing on my screen. All right, now we're pushing to the next page. You see the Wally Mart sign, and we're back in the saddle. And I appreciate you guys' patience. Take and roll, and it's still not 7:30, so we're not doing too bad considering all the problems and even sending you the syllabus. So that's good. All right, so the square root of 25, these are all standard ones that you're going to see now. The square root of a -25, or at the very end, is not a real number. The square root of 0 is 0. I want to show you something. I want to show you two things here. I'm going to take you to the whiteboard because I want you to see these and understand these. So the first one is the square root of 81 over 64. Now, this can be broken down to the square root of 81 like this over the square root of 64. Machine didn't work like that. That's 9 over 8. So the main thing was to show you this part right here, that it can be broken down like that. That's that one. So this looks like this. Can go look to this. Next. The square root of a -25. In fact, technically does not exist, the book says, but one chapter later it says it does. So I'm just going to skip and go to what it does. This is really equal to the square root of a -1 with the square root of 25. Now, if you recall, in imaginary numbers, I equals I squared equals a -1, I to the third power equals a -I, and I to the fourth power equals a +1. Notice, this is the one we use the most. That looks like this one. So now you have the square root of I squared, or the square root of 25. And by the way, everybody knows the square root of 25 is 5. The square root of I squared is if this number matches this number, you always get what is inside, and it's I. And imaginary numbers are always written in the form of 5i. This is like saying apples of 5. This isn't 5 apples. This is the correct way to write it. And technically, it should have 0 in front of it because this is the imaginary part. On some books, you're going to have 7 plus 5i and 7 minus 5i. This is a solution that you'll see in the future, something like that. So they're only getting you warmed up to the 5i portion here. You guys can see how that's done. Move on. Let's see if I got it. Yeah. All right, I got you, Miss Ortiz. You're in. I see you coming in.
Yes, sir. Sorry, I just came back from the doctor.
I thought you came back. I thought you were at that bar.
No, I took my
believe
son
you.
to that doctor.
You still feeling bad?
Well, they did the COVID test on him.
What happened?
He has been sick since last Friday. Since,
Good or bad? You don't have the results, huh?
no, they're gonna send them Wednesday or Thursday.
Okay, so look here, be safe. Number 9, to estimate this, you put this in your calculator. The calculator gives you a huge number. 316, you're going to estimate it. This is to the thousands decimal position. First is tens, that's 3, then hundreds is 1, sevens and thousands. And what they did is they rounded up by taking the position to the right of the 6 and the thousands position and rounded it up to 3.17. So a lot of times you're going to do that. Look at the last one. You take the square root of 460.57, your calculator is going to give you that answer, but rounding it up, that 7 pushes that third number from 1 to a 2. Any questions how to use your calculators for this? Maybe we should do 12. I think people get nervous of those complex fractions like that involving radicals. There's nothing to it. There's 2 ways you could do it, by the way. Let's see if we can do it with 1. So we're going to stop that and just show you that. Hopefully, I got that calculator set up. Yes, I always keep my handy calculator. Okay, so now to do the square root, we're going to do the second square root, and we're going to put 463 underneath it, divided by 557. We're going to push it out of that, enter, and we've got the same thing as in the book, 9.11. We're going to round it up to 9.912. Now, you could have done it this way as well, class. You could have done it like this. The second square root, you could have put in there 463. Then you could have pushed it out. It's divided by second again square root, which is so much harder to do than that easy one. But you can do it this way. We should get the same thing. And you do. So if you don't feel comfortable by putting it all under 1, which you should, you can do it this way and get the same thing. All right. We're going to stop doing that. Go back to the book. This is one of my favorite classes. I don't know why. Maybe it's because of Jose Mundo and all you guys. I don't know, but what it is. Sherry and others. Good group. How many people like Lizeth would contact me and say, something's not right. Here I am sitting on the other side and where is everybody? She contacts me and says, listen, it's not working. And man, that's really smart. That's good. I appreciate that. When people call in saying they're going to be late, that's pretty good responsibility. I like that. Believe me, when I had over 12,000 employees, it was painful. All right, now the square root of x squared minus 9. You can put this in a calculator, except for, I don't know if I'll give you the right answer. But what they want you to do is identify the radicand in here. This is simple. It's the stuff that's underneath the radicand. So, you guys see the book now?
Yes.
Okay, so the radical part, the stuff under the radicand is the x squared minus 9. Boom. The stuff underneath the radicand number 14 is 3x minus 2, and they want you to put 1 in for the x. So 3 times 1 times 3 is 3 minus 2 is 1. You get 1. 5 times out of 15 minus 2, you get the square root of 13. You can see that. All they're doing is telling you to plug in the 0, and you get the square root of negative 2 for the third one. That's all you're doing. Not hard at all. Now the domain. Remember, I'm going to do this one on the other board. I want this to sink in. The square root of x plus 2. Remember that inside the radical, it must be a 0 or a positive number. So what makes this 0 is x is equal to a negative 2. So x can be a negative 2, includes it, anything greater than that. So that's the domain. That's what x is equal to, anything like that. Because remember, 2 and a negative 2 gives it 0. Remember, you can take the square root of 0. And then negative 1 still makes it a 1, and so on. Now, this is where it's tricky. If they write the square root of x minus 2, yes, 2 works. And then it goes, it includes 2 and then goes bigger than that. And that's good. And now the trickiest one. Your mind, see, I'm kind of mesmerizing you. You don't realize it, but I am. I'm mesmerizing you for this next one. Now, in this one, you're going to say, okay, yeah, 2 works. But what works there? It actually goes the other direction. Yes, this is the starred one because this is like on the test where students pick the wrong one every time. But it starts at negative 2. Correction, positive 2. It starts at 2 and goes to negative infinity. Because 2 minus 2 is 0, but 2 minus 1 works, and 2 minus 0 works, and a negative number. So this is really a good one. I hope that makes sense. So all the negatives work because this is a minus sign right here. Minus minus makes whatever negative number work. Are there any questions about this one? Can I get one amen that even heard me?
No, sir.
No, sir.
It doesn't make sense? Is that what you're
Does make
saying?
sense.
Yeah, it makes sense.
Okay, good deal. Thank you. Thank you. All right, let's go on. The uh 16. Look, they want you to know that since this, look at a, the square root of x. If you put that in your calculator, 0 works, and you get this little graph down below that you see there. The square root of x plus 2, which you can see next, makes it more. And let me show you what happens with the calculator. You can see it. I'm not going to waste your time. The calculator is going to show you the same thing as you see below. Yeah, I'm going to waste your time. I want you to see how it puts in the calculator. So we're going to go to our calculator, and we're going to clear this out. And we're going to go to y equals. We're going to graph that second square root. We're going to stick x in there. And you're going to get the graph they just saw. But this is how you graph it, using your graphing calculator. You don't hit enter, you hit graph. And there it is. Now, the next one was the square root of x plus 2. Now, all that does is move this thing to the left because then you can put a negative 2 in here. But let's be sure. Let's leave that graph in there. So let's go down to the next color, red. We're going to put in second square root. You guys can do this all day long too. X plus 2, push it out of that and graph that, and watch. It morphs it to the left, you'll see. I think that's right. See a red one come up, there it is to the left. There you go. Now, if we want to morph it to the right, what would we do? Well, we go, let's make this one green, put out here. We do the square root. I just did that for the fun of it. We're going to put in x minus 2. And what makes this 0 then is a 2. So anyway, we'll graph it. You're going to see 3 different graphs now. There's your third one to the right. We morphed it to the left and to the right. I hope that was helpful and interesting. Tell Dr. Wick I'd rather watch TV or being at the beach. And me too. But as math, I hope that helps. So what they're doing is morphing. The next page will show the morph with the do what you've already done. With me, we've already done that one. We'll see it. So in the future, we'll just come to this site unless something else figures out. So guys, don't worry. There's the other morph right there. We did that. Okay, so everybody okay? We're going to come to the same site on Wednesday. You guys good with that?
Yes.
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 We'll keep it simple if we can.
Yes.
Angela, you there?
Yes, sir, I'm here.
I'm counting on you being there Wednesday now with bells on.
Okay, I'll be there.
Okay, now look at 17. Now, technically, if you have a square inside a square root, remember if that number matches that number, you get whatever's inside. But you get plus or minus. So 17, you're going to get negative 16 and 16. Even though it's a negative one, it's a square. So look at 18. You get whatever's inside, 3b. The b part is always an absolute value. That's all it means. You know, it simply stated is this, without making it complicated. If I have the square root of x minus 2 squared, since this number matches this number, even though it doesn't show it, doesn't show the 2 here, it's known that that's a 2 unless it's marked differently. You get whatever's inside, x minus 2, boom. That's all it means. That's it. And then they make sure that you pick the right number for the x. Since it's a square, it can affect the outcome. And that part you got to test using your math skills. So let's take a look at that. Again, they took the square root of negative 16 squared for 17. And you get whatever's inside, but it's an absolute value. So it's 16. Because everybody knows it's a square. More closely, what we've done is the x minus 1 squared. You get x minus 1 and it's an absolute value. So whatever number you put in there, it has to be positive. Now, cube roots, they're going to have a cube. Now, where are they on your calculator? The cube root of 8. Let's say you didn't know what it was. Again, 25. If you have a cube, match a cube, you get x. The cube root of 0 for 27 is 0. But let's say we didn't know what the cube root of 8 was. How do you do that? Whatever number you come up with. Let's see. I think we'll use what? Calculator. Figure that out. Cube roots. I don't see any cube roots here. Maybe we should go to math. There's a cube root right there, number 4. So we're going to hit number 4. Boom. We'll put in 8. Push it out of 8. Hit enter. You get your 2. Again, under math, there is the cube root. And what is that one? 5. Well, let's hit 5. That means we can put any number we want in there. We can put the 4th root, push it over in that 4th root. 2 times 2 is 4, times 2 is 8, times 6. We're going to put 16. We know that that should give us an answer 2 because 2 times 2 is 4, times 2 is 8, times 2 is 16. We hit enter, boom. So we can make this calculator do anything we want for it. We just have to start learning where those positions are. Believe me, I've been just like you. I remember it's in the calculator. I know I can do it with the calculator, but I got to find the spot. So that only comes from a little bit of practice. And, we'll train you for the test to make sure that you feel good about it. And for the midterm, I'm going to do the same thing you guys are going to get. You guys are going to get, thing's stuck. Oh, come on, Pearson, work for me. You guys are going to get a midterm take home. I hate to say this, but I think my computer is stuck. If it's stuck on the Pearson thing, I may have to shut down and come back in. Jeez. It looks like it. Guys, I'll be here. It's in a loop, I can tell. I'm going to try to get out. Don't go away. You stay there. I'll come back to you.
Okay.
Okay.
All right, that was fun. Are you guys still with me?
Yes.
Yeah.
Yes.
Well, that was painful. I'm sorry. Does anybody remember what page we were on?
370.
371, you said?
Yes.
72.
That,
Oh, 372.
And the 2. Mm-hmm.
thank you, Lizanne. If I can just go back to the book. Sometimes this thing just shuts down. eCampus messes up. So we're going to go to 6. We're almost on 7, I think. Or 6.2, rather. So, Lizette, you know what page 6.2 is on?
Yes, sir. It's 370.
What?
377.
We're on, what, 371 now? So we only have a couple more pages to go.
Sherry said 372.
Okay.
I think we were finished with 371.
Okay. So we can get there. Still getting a Walmart sign yet here on the side. Now I'm going to go and try to get it to where we need to be. And try to get it go. Trying to get there. I think I'm there. And We're actually on 373. Let's see what that takes us. Not going to bring in until I get to the right spot. Let's see what 373 shows, if anything. Oh, yeah. Okay, now we got to go there. So, stop there. You guys should be looking at the book here now.
Yes.
Yeah.
Okay, so now you're seeing a cube. The cube looks like what you see there. Now, look at this. This is the cube root of x. I want to show you one other thing about this. If I put a negative sign in front of it, I'll get the same thing but flipped out. Let's quick look at that. Using our calculator. Put it out. Put it on. Here. We're going to do y equals. And we're going to put on all these. I do see when people leave, by the way, though. So we're going to get down here and get rid of this 5 one. And just go back up to the blue just for the heck of it. And we're going to do cube roots, so we're going to go to, and I see when they come back in. That didn't work out right. Go back. Do that. We'll go to math. Do number 3. The cube. That didn't work either, did it? Yeah. And 4 is what we need. Okay, cube root, and we're going to put in x. This is what I want to show you. So when we go to graph it, you'll see just like what the book has. Exactly. Now, to make it do the opposite of that, that means we're going to change the y with the x and x, y, which is the inverse of this. We're going to go to a graph again, equal. We'll give it some color. We'll go down to red. We're going to do the cube root thing again, so we got to go to math. Hit number 4, quattro. No, we got to do it differently. We got to clear that one out. We got to put in the negative sign. Not the minus, negative. Now we got to do math. Now we can do quattro. And now we can put in our x. And now it reads correctly. And now we're going to get the spider. Oh, no, my bad. Upside down here. Here it is. I don't know. Messed up there for a second. Got graphic. Boom. There it is. And you'll see it was the opposite. And that's called the inverse function. I did syntax here because it had so much stuff on it. I'm blowing up it. So, yeah. But I've worked it enough for a minute. Let's see if it's still there, just for the heck of it. Let's look at a graph. Let's see if it's still there. Yeah, what hurt us is this third one. We needed to clear that one out. Yeah, now, if we graph all those, it'll be no problem. But anyway, that's done for now. And back to the book. So odd and evens. Most people know that odds are odd numbers like 5 and so on. So you can take the roots of them. Even a negative number like 31. Compare 31 you can take the negative because I said you can take a square root of a negative number. That's true. But this is the fifth root. The fifth root, and all odds, you can take negative square roots. That's all there should. And also, 37. Anytime you take a root of 0, you always get 0. The eighth root, whatever it is. So look at 34. Yeah, the two sevens match. You get whatever is inside x. The seventh root of a negative 128. If you didn't know that was on the test, you put that in your calculator. Again, you know how to do that. You go to that one spot, you put the 7, you put the negative 128, and boom. All right, so that's good. I don't want to waste your time on that because we did that one. All right, I think we're going to move on to now page, you said 370 something or another. 8?
I think it's 377.
Does it actually start on 77 or 78?
I think I skipped one already, but I'm not sure. I just wrote it.
So look, you can see now this example, 43, they're just giving you some practices. The same thing we covered. The fourth root of 16 is 2 because we did that one with the calculator. They say 42 doesn't exist, but we do know that's 2i because it's a negative 1 is an imaginary number. 41, don't get fooled that you do take the fourth root of 16, which is 2, but the negative sign in the front of it, and so on. You say 370.
377.
All right, we'll go back.
I already skipped one.
Let's try 377. So again, your midterm exam will be a take-home exam, just like, and I don't want anybody to get anything lower than nobody. And coming to these, you can watch the video. We're very fortunate. Jose has agreed to do it again, so you all have his contact information. You guys should really be successful. Okay, so number 1. Now we're looking at cube roots. 27, 1 to the 1/3 power. I want to go over this in detail, just for a second, because this is important, and this sometimes scares people. When you have a number like 27 to the 1/3 power, this part is the root, and this part is the exponent. So this equates to the third root of 27 to the first power, which gave you guys, of course, 3. Now, let me do one caveat. What if I said 27 to the 2/3 power? That would be equal to the cube root of 27 squared. Now, the you do is take cube root first, which is going to give you 3 from here, and square it, so it's going to give you 9. Must be 9. Let's see if that's right. The cube root of 27 squared. I mean, I could be mistaken, but I don't think so. But I want you to see that you can do these in your calculator. You don't even really have to think as long as you know use your calculator. There we go. That's our calculator. We use that quite a bit in this part of the. We're going to clear this all out. We said we're going to take the cube root. We're going to go to our math portion. We're going to go down to numeral quattro. And we're taking the cube root. We're going to put 27. Upper arrow, because it's squared. Like that. And then push it in. Now, we predicted that we would get, as long as that arrow's not blinking, we're predicting we're going to get 9. Let's see if that's so. There it is. And what we did was, remember, we took the cube root of 27 first. It doesn't matter what order you take it. You could do it this way. You could take 27 squared. enter, you get 729, and then take the cube root of that. The cube root. So we took the square part first, which was inside. Now we're going to do the other part. And that's the square root of 729. So we're going to go second. Square root. I don't like what it did there. I don't know if we can put it in there. Maybe. No, it didn't work out. Let's just do it the right way. That's square root of 729. And push it out. And no, that's not right either. We want the cube root of that. No wonder why. We got to go to our math again. And hit 3, 4. We'll put in there 729. Now we're good to go for sure. And boom, there's your 9. Okay. I just wanted you to see there's a lot of ways to do a math problem. You guys all know that anyway. So x to the 1/2 power for number 3 is the square root of x. Number 2 stands for the root. X to the 1. The 1 is up there, but it's invisible. Example 4. The 5th root of 7xy. The same thing as 7xy in parentheses to the 1/5 power. So all they're doing here is trying to get you to be comfortable with rewriting these from one form to exponential form. So number 5, leave the 8 because it is not involved in the root, so it stays out front. The xy is put in parentheses and is to the 1/3 power. 6 is to the 1/7 power. So you put everything in parentheses. All that is a 1/7 power. 7 is from here. Let's see, 2/3 power. Now they're working it. We already did this one. We got 9, so we don't need to do that one anymore. We use the calculator, and we showed that the calculator can help you easily. I would never do the. I would use the calculator almost all the time. Alrighty, let's see. Almost there. Now the working reverse. You have it in radical form. You move the 9 to the 4th power. You want to move it to exponential form. Remember, the root is always the base. That's the denominator, and the exponent always becomes the numerator. Number 9, does that make sense to you guys?
Yes.
This is number 9 is the basic problem. If you know number 9, you're good to go. Let's go to negatives. Now, anytime you have a negative exponent, it just crosses the line and becomes positive. That's all it is. Anytime you have an exponent that's negative, it must be in the denominator to be positive. And then you take the square root of 9, of course. That gives you 3. Remember, 1/2 power means 9 to the 1st power is square root. Again, 12 is the same thing, becomes the denominator. I'm not going to waste your time in this. They just go to the denominator. 15 is the only kind of complicated one. All you do is flip it. They're both 5/2 then. 3r to the negative 5/2 goes to the bottom. 7s to the negative 5/2 goes to the top. Remember, they just flip. Again, you can't have a negative exponent in math. So 15 is probably the main lesson one. Okay, laws of exponents. You know that if you have two bases that are the same, you multiply them, you add them. Number two, division, you subtract them. Now, they all these you know, you just don't know you know them probably. For example, 3 to the 1/5 and 3 to the 3/5, you add and get 3 to the 4/5. 17, let me give you my example of 17, which is easier to understand than this one. But it's the same concept. This is what they're doing. If you have x and x and x, that equals x cubed, all over x and x, that's over x squared. You simply take the 3 minus the 2 and you get x. The top minus the bottom. And you know that. You cancel them, you get x. You take away 1 from the top, you take away 1 from the bottom. Take 2 away from the top, take 2 away from the bottom. You'd have to have 3 minus 2. You took away 2 from the top. That's all you do. Just subtract them. That's all they're saying. It's that simple, but yet the book makes it look hard. I hope, does this look easier to you?
Yes.
No? Okay. Now the other part is 17 or 18. Whatever number you have, 7.2, it doesn't matter. You take the 2/3 times the 3/4 and you get 6/12, which is 1/2. You could put 7.2 in your calculator 1/2 and you actually get a number. They don't even have it here. It's pretty simple. Again, anytime you have parentheses, you multiply. So that would look like this in simplified form. If I have x squared like this, the 5th power is equal to x to the 10. You take multiply because it's in parentheses. That's all you do. It's that simple. They just make it complicated. They put in a decimal. Okay, we'll put in 7.2. The 2nd power to the 3rd. Well, that number is 7.2. We don't care what it is. It's to the 6th now. That's all they did. They just made a complicated base number to make it look harder. Helps me get more money for my job. Not really. That's good. All right, let's go to the next page. On this one, again, they're doing the same thing. The exponent is always the numerator, the 6 is the base, and reduced it, and that's half. So it's just kind of getting to be redundant now. Unless they come up with a new concept here, I think that'll be it for tonight. We'll see though. They might come up with a real problem here. Trying to remember what I did today, thinking about it. I've done 3 math classes today. Okay. 21, they just walk apart. They're just making it more complicated. 4's got a 1, so it's 4 to the 1 6. The 4 is in fact 2 squared. So 2 squared, so they changed the 4 to 2 squared. 2 times 1 just gives you 2 6. So it's 2 to the 1/3 power. So 21 is a good example of complicating things and telling you to reduce them. Again, 4 to the 1 6, but 2 is actually 2 squared, and that's that one. Look at 23. 22 is the same thing, just more complicated. Same thing. Cube root of 5 times square root of 2. Now, 5 is really to the 1/3 power, 2 is to 1/2 power. So you can actually do these. You have them 1/3 and 1/2. They give you common denominators. Common denominator 1/3 and 1/2 is a 6, so it becomes 2 6 and 3 6. When you multiply them, You have now 5 squared times 2 cubed. All of it's to the 1/6 power, like this. So converting 23 from step 2 to step 3 is where you have to use your brain power. You know the numerator is the exponent, so it becomes 5 squared. You know 3 is the numerator for 2. The base is the same. It's 1/6, so you have that. And they convert it to radical form, radical notation. 5 squared is 25. 2 cubed is 8. This becomes 6 to the square root of 200. 24 would be a good one to practice. It's one. The other one's not really reasonable. You could do it. You won't have something like that, but you might have one like we just did. See what page 381 brings us. I'm not trying to oversimplify it. I just don't want to waste your time. Okay, so 5x, remember 3 is the numerator, 6 is the divisor or denominator because it is the root. It becomes 5x to the 3/6. Remember 3/6 can reduce, so 26 is a review. We've done that one. T to the 20 over 5 becomes t to the 4, and so on. I'm not going to waste your time anymore on this. The only one that's kind of neat looking is this one. This is the square root of the cube root of x. So we're going to convert the x to 1/3 like that. Then we got the square root of that. The square root is really 1/2 power. So you have 1/2 times 1/3, it gives you 1/6. That's a 6 root of x. So 21 is kind of just a fast one, but there it is. All right. Let me do this. Let me go back and see if I've missed anybody that might have. Don't hear your name, that means I have you here. I'm missing Isaiah Green, but he already called in, so I know that, so he's accounted for. I'm missing Gerardo Ramos. Are you here? And April Sierra. Anybody knows anything about April Sierra, please let me know. I'm kind of worried about her. And if anybody has any contact with Daniel Ramos, please let him know. And thank you all for any questions of me. It's the same program as we did before, but Alicia.
All good.
Alicia.
No questions. Thank you. Have a good night.
All right, you guys, have a good night.
Bye.
Bye.
Thank you.
Bye, Professor.
Bye bye.